Assalamualaikum and hi everyone. In this video, I will continue about type of matrices. For number 10, we have a symmetric matrix. So what is the symmetric matrix? Matrix A is symmetric if matrix A is equal to the matrix A transpose, and the diagonal will become the mirror. Okay, so let's say this is our matrix A. When we apply a transpose for the matrix A, we will have this matrix. So as we can see here, every element in the matrix A is equivalent to the every element in the matrix of A transpose. Okay, so let's say we check one by one. For the first row here, we have 7, 3, negative 1. For A transpose, we also have 7, 3, negative 1. So let's say we check for the column number 3. For the matrix A, we have negative 1, 4, 6. For the matrix A transpose, column number 3, we also have the same value, negative 1, 4, and 6. So since we have A equal to the A transpose, so this matrix is called as a symmetric matrix. And another criteria for the symmetric matrix, the diagonal is like a mirror. So diagonal like a mirror means that the diagonal here representing like a mirror, so means that it will reflect the same value. Okay, so what we can see here, we have reflect the same value for the upper part and the lower part of the matrix. Okay, so that is the symmetric matrix. So now for the skew symmetric matrix, the short form is the SSM. Skew symmetric matrix means that if matrix A transpose is equal to the negative of A, and the leading diagonal must contain 0. So this is the condition for the skew symmetric matrix. A transpose must be equal to the negative of A. So this is our matrix of A. So in order to identify whether this matrix is a SSM or not, you have to do the A transpose and then we do the negative of A. So from matrix A, negative of A means that we will take negative value for each of the element. So this one will become 0, negative 1, 4. Okay, so every value here will be multiplied with the negative. Negative of what? Negative of 1. So 0, 1, negative 4 will become 0, negative 1, 4. For the second row, negative 1, 0, 7 will become 1, 0, negative 7. For the third row, negative 4, 7, 0. Okay, so this is negative of A. So now we want to apply for the A transpose. For the A transpose here, we need to transpose from matrix A. We are not transpose from negative of A. We are transpose of matrix of A. Okay, so the first row will become the first column. 0, 1, 4 will become element for the first column. 0, 1, negative 4. For the second row, negative 1, 0, 7 will become the second column. Negative 1, 0, 7. And for the third row, 4, negative 1, 7. 4, negative 7, 0. So now you will check, is it A transpose equal to the negative of A? So if we have A transpose equal to the negative of A, means that this matrix A is a skew symmetric matrix. Okay, so now we have to check these two matrix A transpose and negative of A. So we have the same element for the A transpose and negative of A. So for the conclusion, since A transpose equal to the negative of A, therefore matrix A is skew symmetric matrix. Okay, so now we move for the next one. For the row echelon form. Okay, so there are 3 conditions in order for us to determine whether the matrix is the row echelon form. Okay, so the short form is REF. So there are 3 conditions. The first condition is any row that consists of entirely of 0 must be appear at the bottom of the matrix. Okay, so I give you 3 example here, matrix A, B and C. So we want to check if you have any row that consists entirely of 0. Entirely of 0 means that semua elemen dekat row tersebut value dia kosong. So kalau ada value yang kosong, dia mesti duduk di bahagian bawah sekali. Okay, so we check for the matrix of A. Entirely of 0. So we focus for the any row that have entirely of 0 value. So this one we have the bottom row with the value of 0. So this is the 0 row. Okay, entirely means that every element in that row is a 0 value. Okay, so if you have that 0 value or 0 row, it must be appear at the bottom. So for the matrix A, it satisfies the first condition. For the matrix B, we have a 0 rows, but this 0 rows appear at the upper side of the matrix. It's not at the bottom. The condition must be at the bottom of the matrix. So that's why the matrix of B is not considered as the REF. So this is not REF because it's not satisfy the first condition. Okay. In order to become REF, you must satisfy 3 conditions, 1, 2 and 3. The first condition, if you have 0 rows, must be at the bottom. So B ni, condition yang pertama pun dah tak satisfy. Okay, sebab dia ada 0 rows dekat bahagian atas. So that's why B is considered as not REF. Okay, for the matrix of C here. Any rows that consists of 0 rows appear at the bottom. But for the matrix C here, we don't have any 0 rows. Okay, so if no 0 rows, then we go for second condition. Okay, so for the matrix C here, there is no 0 rows. Tak ada pun row yang kosong semuanya. So that's why we still consider this is as the REF. So if no 0 rows, then it's okay. So we can just proceed for the second condition. Okay, now we go for the second condition. For each row that does not consist entirely of 0, first non-zero is 1. Okay, apa maksud ayat ni? Setiap row yang tak ada 0 rows. So maksudnya kalau dia tak ada 0 rows macam yang saya highlight warna oranye ni, the first non-zero, the value dia mesti 1. Okay, we check one by one. Okay, matrix A yang bawah dengan yang atas ni tak sama elemen dia. Saya tukar-tukar supaya kita nampak kepelbagaian bentuk dia. Okay, so kalau dia tak ada 0 rows, tak apa. But then you tengok first non-zero mesti nombor 1, tak boleh nombor lain. Okay, so check one by one for each of the row. Okay, so dia ada 0 rows. Dia ada dekat bahagian bawah. Okay, 0 rows at the bottom. Then okay. So row yang tak ada 0, for any non-zero rows, the first value must be 1. Value yang pertama yang kita jumpa mesti 1. Okay, 1. Then okay. For the second row, 0, 0 and then 1. Then okay. Nombor pertama yang kita jumpa dalam setiap row mesti nombor 1. So for matrix A, it satisfy condition 1 and condition number 2. Condition 1 satisfy, condition 2 also satisfy. Okay, kenapa condition 1 satisfy? Because we have 0 rows at the bottom. Condition 2 satisfy because the first non-zero is 1. Okay, for matrix B, we don't have any non-zero rows. Okay, so condition 1 satisfy. Okay, it's not compulsory, tak wajib pun untuk ada 0 rows. Okay, so if we have 0 rows, kena duduk kat bawah. But kalau tak ada, if we don't have any 0 rows, then okay, we just proceed for the second condition. Okay, for the second condition, first value must be 1. Okay, semua nombor dia 1. The first value that we see is 1. So the second condition is also satisfied. Okay, so hopefully for A and B, you are clear. Now we go for the C here. We have two condition, condition 1 and condition 2. Condition 1 for any 0 rows. So there is no any 0 rows, then okay. Condition number 2 for first element or first value is 1. This one is 1, okay, but this one is 4. Okay, it must be number 1. So condition number 2 is not satisfied because of this number 4. Okay, first value must be 1. Okay, so this one dia sangkut dekat number 4 ni because supposed to be number 1. Okay, so this is the two condition. Now we go for the third condition. Okay, condition 1, condition 2, condition 3. In order the matrix to become REF, it must satisfy 3 condition. Okay, for matrix A. Okay, before that. Number 3, condition number 3. For each non-zero rows, number 1 appear to the right of leading one. So what is mean by number 1 appear to the 1 here? Means that for each of the row, number 1 must be appear to the right. Okay, dia macam tangga. Nombor 1 yang row pertama dengan nombor 1 row yang kedua must appear to the right. Okay, so what is mean by appear to the right? It look like a ladder, macam tangga. Okay, kita check condition for the matrix A. Condition yang pertama, if you have any 0 rows, it must be appear at the bottom. So we have 0 rows here. 0 rows at the bottom. So condition number 1 satisfied. Condition number 2, the first value for each row must be 1. 1. This one also 1. So second condition satisfied. For the third condition, number 1 appear to the right of leading one. Number 1 for each of the row appear to the right. So you just make a ladder for your number 1 or row that consists of 1. So for the first row, we have 1 here. For the second row, your number 1 is appear to the right. Okay. So condition number 3 also satisfy. So since matrix A satisfy all of the condition, so the matrix A is considered as REF. Clear? Okay, now we go for the matrix B. You still have to check one by one, condition 1, condition 2 and condition number 3. Okay, condition number 1, if you have any 0 rows. So for this matrix, we don't have any 0 rows. Then condition number 1 consider as okay. Condition number 2, first value for each row must be 1. First value for each row must be 1. So we have number 1, number 1 and number 1. Condition number 2 also satisfy. Okay, because for each of the row, the first value that we see is number 1. Okay, but then for the condition number 3, number 1 must be appear to the right. Okay, for each of the row, number 1 must appear to the right. So start from the row number 1. For the second row, number 1 also on the right. But for the third row, your number 1 is not on the right. Okay, it's supposed to be like this. And maybe it's going down, go back there. Okay, so that is what we mean by appear to the right. But for the third row here, your number 1 is not appear to the right. So condition number 3 is not satisfied. So since matrix B only satisfy condition number 1 and condition number 2, that's why matrix B is not REF. Okay, so now we go for the matrix C. condition 1, condition 2 and condition 3. Condition number 1, if you have any 0 rows, it must appear at the bottom. So we don't have any 0 rows. So consider condition number 1 is satisfied. Condition number 2, the first value that we can see for each of the row must be number 1. So condition number 2 satisfied. Condition number 3, number 1 must be appear to the right. So dia macam tangga. Number 1 for the row yang pertama, number 1 for the row yang kedua, number 1 for the row yang ketiga. Every number 1 for each of the row appear to the right. So condition number 3 satisfied. So since matrix C satisfy all the condition, so matrix C is REF. Okay, so that is how we determine whether the matrix is REF or not REF. You have to satisfy 3 conditions, not either one. Okay, must be fulfill 3 conditions. Okay, now we go for the last type of the matrix, reduced row echelon form, RREF. Okay, so in order to become RREF, you need to satisfy 3 conditions before this and another additional condition here. Okay, so means that in order to become RREF, you must satisfy condition 1, condition 2, condition 3, which is from the REF, and the last condition, condition number 4. Okay, so means that if the matrix is not REF, for example matrix B here, matrix B is not REF, this matrix is also not RREF. Kenapa? Sebab dia mesti satisfy 3 condition baru dia boleh jadi REF. And in order to become RREF, dia kena satisfy 4 condition. So kalau 3 pun tak lepas, macam mana dia nak lepas yang keempat? Okay, so that's why kalau matrix tu bukan REF, dia pun akan jadi bukan RREF. Okay, but then if the matrix is REF, it can still become the RREF if the matrix satisfied condition number 4. Okay, so what is the condition number 4? If the column contain leading 1, all other entries in that column are 0. So leading 1 maksudnya dekat condition number 2 kita tadi, if you have a first value is 1, every element in that column must be 0. Okay, so we refer this example. We have A and B. So matrix A, so I write here RREF. Okay, so in order to become RREF, it must satisfy 4 conditions. Okay, condition number 1, if you have any 0 rows, must be appear at the bottom. So 0 rows at the bottom, condition 1 satisfy. Condition number 2, the first value for each of the row is 1. So we have 1, 1. Okay, so condition number 2 satisfy. Condition number 3, number 1 appear to the right. Your number 1 here is move or appear to the right. So condition number 3 also satisfy. Condition number 4, for the first value that you have 1, you have to check entries in that column are 0. Entries in that column are 0. So leading 1 maksudnya the first value yang nombor 1 tadi, kolom tersebut mesti 0. Okay, so this is your 1, column must be 0. So this is your 1, your column must contain 0 value. So leading 1, element in that column is 0. Leading 1, element in that column is 0. So condition number 4 also satisfied. So that's why matrix A is RREF. Okay, so now for the matrix B, we have 4 conditions, C1, C2, C3, C4. Condition number 1, any 0 rows. So 0 rows at the bottom, okay. Satisfy condition number 1. Condition number 2, the first value is 1. The first value for each of the row is 1, 1. Okay, condition number 2 also satisfy. Your number 1 must be appear to the right macam tangga. Number 1 like a ladder. So 1 is appear to the right. So condition number 3 is also satisfied. Condition number 4, if you have the leading one, element in that column must be 0. So this is your 1. Element in that column must be 0. Okay, for this one, no problem. I'm sorry. So for the second column here, no problem because you have number 1 and element in that column is 0. But for the second row here, element 1, but you have here 4. Okay, so it must be 0 element entries in the leading one. Okay, so that's why condition number 4 here is not satisfied. Sebabnya ada nombor 4 kat sini. Dia supposed to be 0. Okay, so that's why for matrix B, this is REF, but this matrix is not RREF. Okay, so REF because satisfy 3 condition, not RREF because not satisfy condition number 4. Okay, so we have finished the type of matrices. There are 13 types of matrices. So for this example, I will discuss a few, number 5 and number 4. Okay, so we do number 5 first. Identify the following matrix. It's either REF, RREF or both. Okay, so remember, in order to become REF, it must satisfy 3 conditions. In order to become RREF, it must satisfy 4 conditions. So if the matrix is REF, it can become RREF. But if the matrix is not REF, so for sure it is also not RREF. Okay, so for number 5, so we do number 5 first. Condition 1, condition 2, condition 3, condition number 4. Okay, condition number 1, if you have any 0 rows, it must be appear at the bottom. So we don't have any 0 rows. So consider condition number 1 satisfied. Okay, for the condition number 2, the first element in each row that consists of non-zero must be 1. Nombor pertama yang kita jumpa mesti 1. But now you have number 2. This one we have 2, we have -3, we have 5. Okay, first element yang kita jumpa selepas kosong mesti 1. So condition number 2 is not satisfied. So once we know that condition number 2 is not satisfied, you don't have to check number 3 and number 4. Okay, no need to check. Because we already not satisfy condition number 2, so we can directly conclude this is not REF. Okay, because in order to become REF, it must satisfy 3 condition. Okay, so kalau dah bukan REF pun tak perlu check lah RREF. Okay, so number 4. So I write here, must be number 1. Same thing here and here. Okay, number 4 here, you have to check 4 condition, C1, C2, C3, C4. Condition number 1, if you have any 0 rows. So we don't have any 0 rows. So consider condition number 1 satisfied. Condition number 2, the first non-zero value is 1. So we have 1, 1, and then 1. Okay, so the first value that you see from each of the row is number 1. So condition number 2 satisfied. Condition number 3, number 1 must be appear to the right. So it looks like a ladder, macam tangga. So number 1 kita for each of the row is appear to the right. So condition number 3 satisfied. So since this matrix satisfy 3 condition, this is REF. Okay, now we want to know, is it RREF or not RREF? Okay, satisfy 3 condition means that this is REF. So now check for the condition number 4. Condition number 4, if you have leading 1 or number 1 for each of the row, element in that column must 0. So sekarang kita nak check by column pula. You have leading 1 here, element in that column is 0. So for the first leading 1 here, column number 2, it's okay. Okay, so this one okay because we have 0 entries or 0 element for the column number 2. For the second row here, your column consists of number 3. So ada nombor 3 pula kat sini. Okay, so tak boleh lah. So this one should be should be 0. Okay, dia mesti 0 dekat sini because we have leading 1. So since we have number 3, condition number 4 is not satisfied. So means that this is not RREF. So even though this matrix is REF, but this matrix is not RREF. Okay, so for the rest of the example here, you can try by your own. Later I will put the final answer for these types of matrices. Okay, so that's all for this video. Thank you.